Hi guys, it's Daniel here, and today we are going to solve another one of my problems, and this is a geometry problem. And I think that this problem is very, very clever, and that it has a very clever solution. So instead of directly telling you the solution, I'll first give you a series of hints on how to attack this problem, and see if you can solve it for yourself. And if you can't, then I will tell you the full solution. So let's first start by reading the problem. A circle with center O is tangent to an ellipse with foci f1 and f2 at exactly 2 points. If one of these two tangency points is labeled T, then prove that the angle f1TO is equal to the angle f2TO. So first, before we solve geometrical problems at all, first we need to draw a diagram, of course. So we have to prove that this angle is equal to this angle. And that might be a little small. Let's see if I can do anything about that. There. Not the neatest, but sure. There you go. So, however, there's also another scenario other than this diagram where instead the circle is on the outside. And I'll draw that for you too. Now we have to prove that these two angles are the same. Okay, so first I'll let you look at these two diagrams, and you can of course draw your own diagrams. In fact, I highly recommend that because these two diagrams are kinda crappy, so sorry about that. So you can first look at these two diagrams and see what you can figure out for yourself. Alright, so then here comes the first hint. We see that we have the foci, the foci and also tangent points, which reminds us of reflections. Think about that. Okay, here comes the second hint. Of course, when we have a tangency point, there's always something you have to draw, and that's a line. And finally, the last hint. You know, in an ellipse, if you launch a ball from one foci and launch it anywhere and let it bounce against the against the perimeter of the ellipse once, it will go to the other foci. Okay, are you ready now? Here comes the solution. So from hint 2, we should draw a line that's tangent to both the circle and the ellipse, like this. And now, from the third hint, we see that if we bounce a ball starting from F1, from here, and we go along here to the end of the ellipse, and then it will bounce back to the second foci, which is exactly the path F1, T, F2. Now, with this line, tangency line that we drew, we know that since this line is tangent to the ellipse at T, then the ball launched from F1 to T to F2 also bounces off this line. And we know that the angle of entrance here, I forgot the actual term, angle of inflection or something like that. Angle of entrance is equal to the exit angle. So therefore, this angle is equal to this angle. However, there's also something else we know. Because this line is tangent to the circle with center O, then that means this angle is right because of simple circle properties. But since this part is right and this part is right, then that means this angle is also equal to this angle. But wait, that's exactly what we're trying to prove. Therefore, we're done. We can also do the exact same construction on the other circle. on the other diagram, that is. We can first draw a line here, and then by the angle, by the bouncing ball properties, this angle is equal to this angle. And since this angle is right, this angle is right, then that means this angle is equal to this angle. And we're done. Hi guys, it's Daniel here, and today we are going to do another coordinate geometry problem. And this problem is 2002 AMY 2 problem number 15.